Suppose I have 7 shirts and 4 ties. How many shirt and tie outfits can I make? Lay, start with you.
I got 28 shirt and tie outfits.
Yep, 28. 4 times 7 is 28. That's the correct answer. That's the correct answer. Good. Okay, let's go to the next one. For each of 9 colors, I have 1 shirt and 1 tie of that color. How many shirt and tie outfits can I make if I refuse to wear a shirt and a tie of the same color? Matthew.
You first do 9 times 9, which equals 81, because there's 9 colors. But then, because he doesn't, or they don't want to have an outfit of the same color, you have to
Deduct 9.
subtract that 9,
Yep.
and then you'll be 72.
Yeah, but you can do
I
it
forgot to
in a.
subtract 9.
Sorry, say it again.
I
What?
got that problem wrong because I forgot to subtract 9.
Yeah. So what you need to do is you need to write, either you can write 9 times 9, which is 81, and then minus 9, which is 72. Or you can say, I have 9 ties that I can wear, but I can't wear one shirt. In any tie I choose, I cannot use one shirt. So I can only use 8 shirts. So that is 9 times 8 is 72. That is what I would have thought, but this is also correct. So it's not that it's wrong. It's just 2 different ways of understanding the concept, and I'm okay with both the ideas. Good. Let's go to question number 14.2.3. Will, it's your turn. In how many ways can 5 people stand in a line?
I got 120 ways.
Yeah, that's right. What you need to do is the first person that can stand in the line is any person. That's 5. The next one can be only 4 out of the 1, and then it's times 3 times 2 times 1. So you get the option of 120 options. 120 options. You can make the line work or be with 5 different people. A shopkeeper sells house numbers. She has a large supplies of the digit 1, 2, 7, and 8, but no other digits. How many different 3-digit house numbers can be made only using the digit in her supply? Only a digit in her supply. So remember, she has a large supply of digits 1, 2, 7, and 8, but no other digits. How many different 3-digit houses numbers could be made using only the digits she has in the supply? So let's see. Will, you talk? Matthew, you talk? Mark? Oh, Julia. Mark, first of all, and then we'll go to Julia. Mark, 14.2.4. What is the answer?
A shoekeeper sells house numbers. She has a large supply of the digits 1, 2, 7, and 8, but no other digits. How many different 3-digit house numbers could be made using only the digits in her supply?
Yeah. So here is the house numbers. How many digits can, how many numbers can she make?
She can only using those 4 numbers.
Yeah.
Correct?
Yeah.
She can make 3 times 4 was 12 digits, I think.
No, she can make 4 times 4
4
times 4. That is 64. Okay, 4 times 4 is 16. 16 times 4 is 64. That is the number of houses that she can build only from 1, 2, 7, and 8, because she has 4 numbers. One of the 4s can be, they can be 1, 1, 1, 2, 2, 2, 7, 7, 7, or 8, 8, 8. There's no problem because they did not say that we cannot repeat the same numbers again. So it can be 1, 1, and then another number, or it can be 1, 1, 1. So we need to take all the options. All the options is 64 options together, and that's what we need to do. Okay, Julia, question 12.4, 14.2.5, please. 14.2.5.
How many four-digit positive integers are there such that the leftmost digit is odd, the second digit is even, and all four digits are different?
How many four-digit positive integers are there such that the all leftmost digit is odd, the second digit is even, and all four digits are different? So you have four digits that can be here. One digit, 1 second, 1 second. Yeah. There is four-digit number, 1, 2, 3, and 4. What is the first thing that we can say? We have a first is has to be an odd number. What are the odd numbers that you know? How many odd numbers do you know? 5. Lovely. That's the first number. Now, how many even numbers you know?
5 as well.
5 as well. Fantastic. 5 as well. Now he says all four digits are different. That means what can be a number? What number
So
can you
then
put
there's
here?
4 and 4 for the rest. 4. If this
No.
one's
Why 4?
because like one of the if this one's even, then there's only 4 left because there's already one
Yeah,
of
but we
them.
don't want we don't have any restriction of having even or odd. So we can say that we
Yeah, so
have here
if
8
it's odd,
options.
it's still 4. So then 4 times 2 is 8. So
Yeah, we have 4 even and 4 odd. That's what you want to say. But I'm saying let's take out the 10 numbers that we have 0 to 9 and take out 2 numbers which are already in the 5 and the 8, and they cannot be there. Okay, they cannot be there, and then what is left is what we have. Now,
7.
what is the next number? What will be the next number that we will multiply with? Because the fourth number
7.
also has to be different.
7.
6? Why
7.
6?
7.
7. 7 is a better answer. 7 is a better answer. So here, 7 times 8 is 56. 5 times 5 is 25. So 25 times 56, okay, which is, I think 140. I think. Check me out. 56 is 28, 14, yeah, 140. Right?
1,040, I think.
1,400, I think, yeah. 25 times 56, 1,400. 10 I'm missing. Yeah, 1,400. So there are 1,400 options that we can arrange a four-digit number that the first one will be even, odd, the second number will be even, and the third number can be any number only that cannot repeat the numbers that were in the even or the odd number, and the fourth number has to be also any number but cannot be the first one, not the second one, not the third one. So it has left only with 7 numbers that has to do the cycle with that. That's all. So this is really a very simple question to work with. If you will see, this is really very much understanding 7 times 8 is 56, times 5 is times 5 is 280, and times 5 is 1400. That's exactly the correct answer. Fantastic. Good. Let's go to the next one, please. Let's see who has not answered the question yet. Is there anybody else that I see? Okay, no, then Lay. Start from Lay again. Lay, it's your turn. 14.2.6.
when the order of the digits of 2,552 is reversed, the number remains the same. Such a number is called a palindrome. How many integers between 100 and 1,000 are palindromes?
Good. Okay, come on.
So
Remember,
for
it's
the
between 100 and 1,000. It's not 4 digits. It's only 3 digits. That means the 3-digit number should be only between 100 and 999. So we have only 3 digits. Although
So
they
the-
gave you an example of a 4-number digit, 2552 is reverse, is called a palindrome. But even 252 is called a palindrome because you can read from here 252 and read from here 252. So that's what we are looking about. We are looking about 3 digits number, not 4 digits number. So now we will understand that we are doing 3-digit number that we have to start with. Okay. What is the smallest 3-digit number that is a palindrome? That is a palindrome. You know, 101. Yes. 101 is the smallest one. Now, what we can do is run with this guy from 0 to 9. That is 10 numbers, right? So we make 101, 111, 121, 131, 141, 151, 161, 171, 181, 191. They are the 10 numbers. Now we can change this one to 2 and do the 10 again, and then the 3 and the 4 and the 5. So we have again 90 numbers. Times 9 is 90 numbers that you can have. You don't have more than that. Anybody can find more than that? No, I don't think there is any more numbers than that, because we have to have the first number and the last number the same. Okay, now I am going a little bit outside the box, although they did not ask us here. But let's say if I had 4 numbers and I wanted to use a do a palindrome number, how many numbers do I need, or what is my smallest number? Let's start with smallest number. My smallest number is 1001. This is my smallest number. I cannot have smaller 4-digit number smaller than that. Okay, which is a palindrome. Good. Now tell me, how many numbers can I make this number, or how many numbers I can make palindrome numbers? How many palindrome numbers do I have where there are 4-digit numbers? Lay, what is the highest palindrome number that you know in the 4-digit?
9,000.
Yeah.
999.
9,999. That's a palindrome number. You read it backwards or you read it forward, it's the same thing. Lovely. So look at these numbers. These 2 numbers are your answer. So if I say my last number is 99 and my first number is 10, how many numbers that I have from 10 to 99?
90.
90. 90, yeah, 90 numbers exactly. So I have 90 numbers. That's exactly the 90 numbers I will find. Look why. Because if I say 1001, let us say the next one, 1111, I can say 1221, 1331, and so on. I can go from 10 to 11 to 13. 19 will be 19.1, and 21 will be 21.12, and 31 will be 31.13, and 51 will be 51.15. I mean, I can do any number I want. So I'm changing only the first 2 numbers. So I need to count all the numbers from 10 to 99, because the other 2 numbers are automatically defined. They are the opposite numbers of the number before. So I can tell you that if I count from here, from 10 to 99, 99 numbers, I will automatically get these numbers are the opposite of the numbers before. So I'll have exactly 90 palindrome numbers. This is really one of the things that we ask in the exams. So remember, this is really very much about understanding the palindrome. The palindrome is a number that can be read from.
Wait, can you show us again?
Sorry?
Can you show us that again? I didn't.
Okay, I'm going to repeat it. So I said, if you have a 4-digit number, 4-digit number is made of 4 digits. So my smallest number I can have as a palindrome, that means I can read it from this side or from this side, has to be 1001, because 10 is my smallest number. I cannot write here 09 here. I cannot write here 08, because 08 will not give me a 4-digit number. It will give me a 3-digit number, because 0 in the beginning will not help me. So I have to start with 10. 10 is the smallest one. Then I can go to 11, 11, 12, 21, 13, 31. So I'm really counting the first 2 as the numbers that can run forward from 10 to 99. So if this is 1001, this will be 9999. So how many numbers I have from the 10 to 99? I have 90 numbers. So I have exactly 90 numbers of palindromes that are between 1,000 and 9,009, or 10, between 1,000 and 10,000. That means 1,000 included and 10,000 not included. I have exactly 4-digit number. There are 94 digit number. which are palindromes. Okay, I have 1,000 number between sorry, I have 9,900. No, sorry, I have 9,000 number in between 9,000 and 9,999. But I have total of 90 numbers that can be considered as palindromes, because you can read them from the front, like from the left to right, and you can read them from the right to left, and they will show you the same number. That's what it is called palindrome. Okay, you understand it now, Will? Good. Okay, let's go on to the next two questions, which have stars. Stars means a little bit more challenging question. Suppose that I have 5 different books, 2 of which are math books, and how many ways can I place my 5 books left to right on a shelf if I want a math book on both ends? So how many ways of option I have?
I got
Clear?
12, but I'm not too sure if it's right.
Why 12? Why 12? Tell me.
I forgot. I was just like
Okay, so
thinking
you have
like
2
these
books of
two
math,
are
right?
on
Yes,
this side,
Lee.
have to be on this side. Then like you try to figure out this, and then you like.
So let's say we have
between
math,
these three.
English, chemistry, biology, and math book. Okay, so we have to have math here, and we have to have math here, but we can have the math of grade 5. Let's say this is grade 5 and math of grade 7. So we can have math of grade 5 first and math of grade 7 here, and then we have math of grade 7 here and math of grade 5. That means we'll take this thing and multiply by 2. Okay, that means we'll work as if the math doesn't care, and then we'll multiply by 2. What is the options we can have here? We can have any 3 books here. Then we can have only from the 2 books left, and then we can have only 1 book left. So really what we have is, we have 3 times 2 is 6, 6 times 1 is 6, and times 2, which is the math, we have 12 options. 6 times 2 is 12 options. Yes, you're right. They have 12 options of how you arrange the books. You cannot say, I'm going to arrange 5, then 4, then 3, then 2, and then 1, and that is my 5 books. No, because you're right. You can choose any book, but you have to choose math. So the math has only 2 options. So you have 2 to choose here. Then you have only, and then you have only 1 option to choose here, because you have 2 math. If you chose here, then 1 is here. Now, on the 4th place, you have only 3 books to choose. Then on the second one, you have only 2 books to choose. And the last one, you have only 1 book to choose. So 2 times 3 times 2 times 1 times 1 will give you exactly 12 options. That is the 12 options. Okay? That is how we do it. Okay, let's see the last one. Let's see who can solve it. I want you to tell me, how many integers between 99 and 999 contain exactly 1 0? Yeah, Ella, I can't hear you. You're muted. Yes, you can talk to.
So for
Yeah.
14.2.8, I got 162 options, because for like, so the 0 can only be in the second spot and the 3rd spot, because the first spot then wouldn't be a 3-digit integer.
Fantastic.
So, huh?
Yeah.
And then so there are 9 integers to choose from in
9
the first
integers,
one.
yes.
And then there are 9 integers in the second one. That's if the 0 is at the end, equals times 1 equals, because that one has to be 0, equals 81. And then the second choice is 9 times 1 times 9 equals 81. 81 plus 81 equals 162.
Yeah. That's 162. That's 162. Fantastic. Let's see the thing and put the solution that Ella said to us. We'll put 162, and we'll see if Ella was right or Ella was right. Ella was right. Yeah, that is what it says here. Ella was completely right. Where is my draw? This way. Here, 162. Two-digit number with 1 0. Yes, because we have 9, 9, and 0, and 9, 0, and 9 numbers. So we can have 9, and once you chose the 0 in the middle, then you have only 9 options to choose from the last number, because the last number can be 0. There's no problem. Yeah. No, there's only 1 0, so you cannot have 2 zeros in the number. Yeah, so that is one of the options that we did, and 162 is the right answer. Fantastic. Let's reset this. 1 second. Let me make it mouse. Reset. Okay, and clean it from the drawings, and now go to the next one. Next one. Good. So here is a casework. Okay, look at the casework, and it is something that you will do it in your thing. The figure to the right represents a roadmap between 4 villages, A, B, C, and D. The arc indicates paths between the various villages. How many ways are there to go from A to D along the path? If you along the path from A to B, B to D, and A to C, and C to D, and then you can go from A to C, and from C to D. How many paths there are? So what do you say? What is the answer? So the figure to the right represents a roadmap between 4 villages labeled A, B, C, and D. The arcs indicate paths between the various villages. How many ways are there to go from A to D along the paths? If you can only move left to right, okay. That means,
5
for
times
example,
4
you can't
times
go
3
A,
times
B,
2.
A, B, A, B, A, C, and D. No, you cannot do that. A, B, A, B, A, B, A, B, A, B, A, C, and D. No, you cannot do that way. So only on the path, you can go only from the left to the right. So from here to here, you have 4. From here to here, you have 3. That means 12 paths if you come from the top side. So if you come from this side, we have 12 options. If you come from here, you have 2 times 5 is 10, which is together 22 options. Yes, Lay. Yes, Lay. You want to say something? Sorry?
I was going to say 22.
Okay, good. Yeah, but I wanted to know from where, how do you come to 22? So we have 4 year and 3 year. 4 times 3 gives you 12. Here we have 2 year and we have 5 year. 2 times 5 is 10. And 22 is the maximum routes that we have. Okay. Remember, we can only go this way or go this way. You cannot go this way, this way, this way, and then go here. You cannot do that thing. So you have to keep it there. Go to the next one. Problem 14.14. On the island of A, B, C, D, E, F, the alphabet has only 6 letters, and every word in their language has no more than 3 letters in it. How many words are possible? A word can use a letter more than once, but 0 letters does not count as a word. So how many letters, has no more than 3 letters in it? How many words are possible? Okay. Yes, Ella. You want to say the answer, please? Again, you're muted. I can't hear you.
Okay, so there are 6 letters and there's only 3 letters. So there's a choice of 3 letters in a word, 2 letters in a word, or only 1 letter in a word.
So let's start with 1 letter in the word. How many options we have?
6 times 1 equals 6.
Okay, 1 times 6 is 6. So that's first. When we have 2 letters, that means 2 letters like this. We can have the 6 and 5. Okay, so we have 6 times 5 is 30.
But it says a word can use a letter more than once.
Okay, then it's 36, right?
Yeah.
36, 6 times 6. Good. Now what about 3 letters?
6 times 6 times 6 equals 216.
216. So we have 216.
So you have 6 plus 36 plus 216, and that is
Come on.
200.
No, that's not 8. It's not 12. It's not
Oh,
12,
wait.
it's 18 at the end. 6 plus 6 plus 6.
I got 258.
No,
No, no.
wait, I messed up.
258.
Yeah,
These
258.
No, it cannot be
are not
258. Yeah, it can be
I got
258 is the right answer.
yeah, I said 258.
258. 6 plus 6 plus 6 is not 2 in the. Somebody wrote 2 in the bottom. That was
Yeah.
wrong.
because I thought these digits were aligned.
No, no, they're not aligned. Okay. Yeah. So 258 words in a language is very little words. I don't think that in English we have 258. That's good. Okay. How many pairs of positive integers a, b satisfy a squared plus b squared, a squared plus b is bigger than 24, is smaller than 24, sorry. How many numbers, how many pairs of positive integers a and b can satisfy a squared plus b?
It can't be 0, so we only have choices of 1, 2, 3.
Yeah,
and
it cannot be
4.
0, but we have one square. If you put
So
one
if
square,
A
it
equals
will be
1,
one square is 1 plus
So-
a is 1, b
1
is
squared
23.
plus
23.
so B has 23.
Yeah,
and
b
then
is 23.
A is 2, 2 squared is 4, 24 minus 4 is 20.
20.
And then you have 15.
3
because-
times 3 is 9. First of all, you forgot 9. 9 minus 24 is 17.
Wait,
No, sorry, not 17, 15. I meant 15. That gives you 24.
and if and then
And
24 minus
4
16.
times 4 is 16. 16 plus what gives you 24? 8, 7? No, 8.
8, 8.
8. And then 5 times 5 is 25, which is too much. Okay. That's 4 options. Is there any other options? Come on, guys. Is there any other options? I say
No.
there are at least 4 more that come into my head just now.
Oh, so
Yes, Lei. Lei is raising her hand.
I think there are 22
22. Why 22, Lei?
because it could be anything from 1 to 22.
1 to 22. But how do you do 22 squared?
think-
22 squared is
I
not less
think
than
there's
24.
a lot more than that.
No, like
Oh, sorry. First of all, it should be less than 24. That means, my bad, we need to make all of this not 24, not 20, not 15, not 8. We need to make it smaller. That means we need to make it integer. So this has to be 22. This has to be
So
4
if
times
A equals 1,
19.
there are 22 choices for B. And then because like you take 23 and then you subtract 1 because it can't possibly be that. So then you get 22 and you do the same thing for the rest of them. So it's 22 plus 19 plus 14 plus 7.
No, yeah, but that's not what I'm asking. What will be the next one? What pair of numbers will be the next one? So we said A should be here equal 1, B is 22. We have A equals 2, we have B equals 19. We have A equals 3, we have B equals 14. We have A equals 4, B equals 7. And we said after that we cannot do because A is 5. If A is 5, it will be 25. But 25 is bigger than 24, right? But
Yeah.
we can say minus 2. Right? Ella, take that butterfly or whatever you have on your screen. Come on, be good. So this is, I can do minus 2. A can be 6. 6 is 36. 36 minus 13 minus 13. So B is minus 13 will give me 23. A is 7. 7 times 7 is 49. And 49 minus a number which is 26 will give me 23. So you can see I can do a lot of numbers. I can make any number I want to choose and I will get the right answer. Okay, I can make any number. I can choose also -1. because -1 will give me the same answer, -1 and 22, because -1 square is -1 square is 1. Okay, -2 square is 4. -3 square is 9. All these numbers are the same numbers that we have already chosen. The positive and negative will give us the same B. Okay, this is a question because they said how many pairs of positive integers, you see, only positive integers. So you can say that there are only 4 numbers. If they had said negative numbers also, then we can say we have infinite numbers, because we can do negative exponents, and then we can do negative b's. So it can be negative a's and negative b's. So it's a full range of all the numbers that can be. That means it's infinite. Okay, it can be a very big number. Look at the answer of that they gave. I think they decided that it should be 4 numbers only. Yeah, they said only 4. You can see. So we have case 1, A can be 1. And when A is 1, we must have B is 23. Okay, less than should be. Thus, there are 22 possible choices for B when A equals 1, since B equals any number between 1 to 22. Then case 2, when A is 2, we must B is number is 20. So we can have, there are 19 possible choices for B when A equals 2, and then 14, and then 7. We need to add all these possible possibilities. That means 22 answers from here. 1 second. So 22 answers from here, 19, 14, and 7 gives you how many numbers? Gives you 30, 41, 41, 45, 55, 55 plus 7 is 62 options. So we have 62 possible answers. That is what we need to do. Okay, good. Now, that is one of the things that you need to remember. Okay, let me go down to this guy, and let me go down to this one. And that was 14, 16. And remember one thing that we say here. You can see what it says. How many pairs of positive integers, A and B, satisfy A square plus B is less than 24? Less than 24 means it's not exactly what number I need to put. I can put 23, 22, 21, 20, any number until, as long as it's less than 24. So I have 22 options in the first one. Yes, Ella, you're raising your hand? No, okay, there is something behind you. Okay, 22 and so on. That is what we did. Okay, let's see the next one. A digital clock shows the time in the format of HHMM. On a certain day, what is the number of minutes? 7:59 and 2:59. What is the number of minutes between 7:59 and 2:59 p.m. that HH is greater than MM? Okay, what number? Okay, that is a really confusing one. Let's read it again. A digital clock shows time in the format HHMM, hours and minutes. On a certain day, what is the number of minutes between 7:59 and 2:59 that the hours is greater than the minutes? That the hours is greater than the minutes. How many times you can show it?